Okay, so this is the practice, the 6-question set I gave you for practice. All right, and this is the first question we're going to do. So I'll let you look at that quickly. You can pause it, obviously, to look at it. All right, so number one, again, this is all calculator because we're going to be taking it by ourselves, so whatever. But in this case, we're looking for the region bounded by the square root from 0 to 4. We're looking for that region, and all we do is integrate it. And if we have to do it by hand, if they want us to show how to do it by hand, we could do that. Okay, we just add 1 to the exponent and divide by that number. Adding 1 to 1/2 gets us 3/2. Dividing by 3/2 is the same thing as multiplying by 2/3. And then we evaluate this at 4 and 0, and we end up with 16/3. And that's our area of that region. All right, that's part A. Part B is a little more involved. It says find the value of h such that the vertical line x equals h divides the region into 2 regions of equal area. So we're looking for a value of h right there that divides this region into 2 equal pieces. Well, we know the full piece is 16/3, therefore we know from 0 to h of the square root of x must be equal to half of this. So half of that is 8/3. So from here we integrate the exact same way we did. So this becomes 2/3 x to the 3/2. And we evaluate it at h, and we evaluate it at 0. 0 just goes away. So this becomes 2/3 h to the 3/2 equals 8/3. And now we need to solve that problem. All right, so let's go over the general part real quick. We're looking for 2 equal pieces. Well, if the whole piece is 16/3, then an equal piece would be 8/3. We don't know our unknowns. So this is our variable here. We know how to integrate this and evaluate, so that's our process. So from here we just multiply both sides by 3 to get rid of the 3's, dividing by 2, and we end up with this. So that is multiplying both sides to get by 3 to get rid of the 3, and dividing by 2. Now from here, this is a rational exponent. So what we've done in the past is we've taken this, we've undone these rational exponents. In this case, we square it, which brings us to 16, and then take the cube root. So this becomes h, boom, boom, squared equals 4 squared. The 2's cancel out. I'm left with h cubed equals 16, and then I take the square of the cube root. And that's our answer. Okay, number 2. Here's our question. If we see one of these on the test, which we most definitely will because it does covers a lot of bases with their types of questions, we get very happy because we have a really good skill set here. We have our integral function, which represents the area under this curve from 0 to whatever. We have these 3 questions, which we're going to talk about the derivative of the integral, the fundamental theorem of calculus. And then we talk about relative mins and maxes and crossing over the x-axis. So this is a really good question for us. Part C is a doozy, but we'll talk about that. Okay, so I'll let you look at this. Okay, so you already have the picture to look at. So when we're talking about G of 4, we are talking about 0 to 4 of this function f of t dt, which means we are looking to calculate the area under this curve from 0 to 4, all the way to here, right? So this comes out to, just talking about area-wise, 1, and this comes out to area-wise 4. So when we're going from left to right, this becomes -1 plus 4 or +3. Okay, that's g of 4. So this is +3. G prime of 4 is equal to this integral, the derivative, so f of 4. So that's the first fundamental theorem of calculus. Therefore, g prime of 4 is literally this value right here, this y value right here, f of 4. So that becomes 0. So that's 0. And g double prime of 4 is equal to f prime of 4, which instead of being the y value at the graph, it's the slope at the graph. So this is -2, the slope of that line. When we calculate that, change the y, we'll change the x. Boom. So that's part A, and pretty straightforward. Okay, that's part A. Part B. Does G have a relative minimum or relative maximum or neither at x equals 1? So we look at this, a relative min or relative max. Does G have a relative min, max, or neither? So don't try to make sense of the graph. Try to make sense of what the question is. So when we're talking about anything here, we're talking about any relative min or max with G, we're talking about G prime equaling 0. That's our possible min or max. And so really, remember, we just talked about it up here, G prime is equal to F. So really we want to know when F equals 0, and then we want to know if it goes from positive to negative, or from negative to positive, or neither. So we just look at our graph and we see when is F equal to 0, 1. Check, and it goes from negative to positive. Therefore, it is a, remember, going down and up, it's a minimum. So therefore, at x equals 1 is a minimum, because it goes from negative to positive. And these are questions. These are not solutions. They're questions. Okay, so part C is pretty tricky. Okay, suppose that f is defined for all real numbers x and with a period length of 5, which means that this thing is a periodic graph, just like your sine cosine graph. And if you look at this graph, you have two periods here. It goes up, over, down, so on and so forth. So this thing repeats every 5. Every 5, okay? The graph above shows 2 periods, blah, blah, blah. Given that g of 5 is 2, right, that's from 0 to 5 all the way, because remember this is also -1, right? So if I go from 0 to 5, I get -1, +4, -1, so a total of 2. Find g of 10 and write an equation for the line tangent to the graph of x at 108. So g of 10 is the same thing as going 2 periods. All right, which means g of 10, g of 5 is 2, so 2 times g of 5, that's my 2 periods, is 2 times 2, or 4. So g of 10 equals 4. My explanations here are more for you than they are for the grading or anything else. I want to be thorough, obviously, but I don't want you to feel like everything I write here is what you need to write to get full credit. Okay, what you need to write to get full credit is explained here on these types of things, and explained here. Right? All right. So secondly, they ask for G, the line tangent to the graph of G at x equals 108. So this question is like, what? But we know, generally speaking, what we're supposed to find is 108, comma, g of 108. In other words, my y value. That's my x. That's my y. And I need to know the derivative. I need to know the slope, which is g prime at 108. So before I get all stressed out about this, I need to say, okay, if I'm looking for the line tangent, we've only done 1,000 lines tangent to the graph at 108, which means I need 108, comma, g 108. and then any g prime of 108. So let's figure this part out first. G of 108 would be equivalent to going over this period, going over this graph, boom, 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 all those different times. And remember, accumulating, for every 5 I go, I accumulate 2, right? For every 5, so g of 5 is 2, g of 10 is 4. So even just knowing that part, knowing that you have, for every g of 5, you equal 2, then when you go g of 108, again, it doesn't go distinct, it doesn't go exactly into it, you have 21 periods. G of 108 is equivalent to 21 periods, so 21 periods, so 21 times g of 5, right, times the value of g of 5. So this is 21 times 2, or 42, right? So 21 times g of 5. We've gone through 21 times. That means 5 goes into that 21 times. But then I have g of 3 left over, because I've gone around to 105. Then I have g of 3 left over. And when I look at g of 3, I'm talking about going from 0 to 3, and 0 to 4, I'm sorry, I'll go like that. This piece right in here, oh, there's a different color. This piece right in here is equal to positive 3, right? It's equal to positive 3, and the reason it's equal to positive 3 is because of geometry and so on and so forth. So 3 plus negative 1 is going to be positive 2. So g of 3 is positive 2. So this is also just 2. Therefore, g of 108 equals 44. Okay? That's my y value, right? That's my y value. Now I need to know g prime of 108. Well, the same process of getting to the value of g of 108 is g prime. G prime is going to be the same thing as, I go all the way around 100, blah, 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 and then I end up right here. So g prime of 108 is exactly the same as g prime of 3. And remember, when we're talking about g prime, we're talking about f at that point. So therefore, g prime of 3 is simply my y value at that point, or 2. So g prime of 108 is equal to 2. All right? And therefore, I'm going to write this in different colors. It's my thing. And this becomes y minus my y value 44 equals 2 times x minus 108. That's it. It's a horrible red. I'm going to throw that marker up. My kids get into it. Little nightmares. Okay, so maybe write it with a little bit clearer marker. Point slope is perfectly acceptable, and there's your equation.